Hello my friends of Hatari Labs, welcome to this tutorial. In this tutorial we are going to do something really interesting, that is that we are going to define the leaf area of different crops. Okay, so this leaf area will be done with Python and Scikit-Image. There is a discussion, okay, because these points come from the crop detection algorithm that actually you can find it here in our blog. Uh, okay, so this is the tutorial to represent the crops. However, from representing the crops, you can also interpret the leaf area. Okay, and we have done this interpretation for some of these points because the this actually takes some time. Okay, but we are going to explore that, and then you are going to, for example, run this for all the crops, and then you can see, but we can still do analysis on the results as well. Okay, so let's start. We are going to I'm going to discard. Okay, and as well. Okay, let's start by setting anaconda prompt. You are going to receive in the description of the video the all the files, so and a zipped file that you have to place under your documents. So please place it under your documents, and from here you launch Jupyter Lab. Okay, so what do we have? We have here the shapefile, that is birch crop, that is the or birch crop 2, which whatever you would like. Okay, so these are the identified crops. Okay, and we go here to scripts, and here in scripts we are going to do a new notebook that is going to be called part 1. Okay, that is amazing. Okay, what we are going to do next is that we are going to open the required packages, NumPy, Seaborn, Rasterio, GeoPanda, Scikit-Image. Okay, great. And then we are going to open the orthophoto, the drone orthophoto. Okay, and then we need to explore the resolution. Okay, and the units. Okay, so we are using meters. Okay, and the resolution is 20 centimeters. Okay, great. So let's see. Okay, based on the, okay, by measuring the plants, the diameter is 2.5, so we need to know which is the amount of cells that will enclose one that is 50. Okay, uh, we do a grayscale version of the image, and this is to enhance the contrast. Okay, this is just grayscale version of the index. Okay, and then we are going to open the points of the olive points. Okay, birch crop 2 as olive points, and then we open that. For example, we have for the first, this is the X for the first crop, and well, this comes from the documentation. We need to do a Gaussian filter in order to improve the accuracy. Okay, and then we are going to test this for one. We are going to test this for one crop, because this we are going to. Okay, and for this crop we create a circle of 20 points, and from this we create snakes. Okay, so this snake, we gave the image, we gave the circle in points, and some parameters you can play with because there is a lot of parameters, okay? And we say that this has to be closed. Okay, so this is the snake. And then here we can plot the snake for this crop. Okay, so we have here the snake, and this is the active contour. Okay, here the feed is pretty interesting. Okay, you can play around with the parameters as well, and let's go to the documentation of active contour inside Scikit-Learn. Okay, but we want is to do, okay, we are going to get a function that for the snake, okay, because the snake has coordinates but in row column, and then we want to create the snakes in coordinates xy. So this is the function, and then we do this for loop, okay, that will go for every point. It will create a snake, it will create the init, and from the it will create the init, and from the init you will have a snake, okay, and then you will have a list of the snakes in xy. Okay, this takes time. Okay, this takes time, so it takes around 10 minutes, and we are going to make a pause here. Okay, it has finished. Okay, so it's just running for 40 points. Okay, so if you have more points, you have to run it for all your points. Okay, but however, it will take more time. So for the purpose of this tutorial, so we are just going to run it for this for 40 points. Okay, so we can plot the snakes. These are the snakes. Great, the 40 snakes. And then we can create a shapefile because we need to, so it will be called leaf area.shapefile, and then we can plot the leaf area. So these are those shapefiles. However, if you go to this is the image, these are the points, and this is the leaf area. Okay, great. So you, okay, I strongly invite you for you to you invite you to see, to evaluate the this algorithm, okay, and to see if that fits to for your needs. Okay, and then we can do a histogram, and this is pretty light, but however very powerful, where we can do an histogram, a histogram of the leaf area, and then we can see the distribution of the leaf area from the minimum to the maximum. Okay, so this is all for this tutorial. We hope that you like it, and it is my invitation to keep to to evaluate the code, okay, to follow all the steps. Yes, all the data is on the description of the video, and that's to remind you that we are a platform of knowledge sharing in water resources. So if you want to check the diplomas that we have, the courses, the asynchronous and live courses that we have, you can look for our our website shop.qatarilabs.com. And just to remind that by taking our courses, you are supporting our research. Okay, have a great day. Bye.